motion problems, distance problems, where they have equal distance. We're going to look at. Y'all remember your distance formula problem? Yeah, your dirt problems. This is an example of one. Roger made a trip on Sunday, and Judy made the same trip on Monday. Do they tell how far they went? Do we need to know how far they went? No? Because we know that they went the same distance. It tells us Roger traveled at 12 miles per hour, Judy traveled at 20 miles per hour, so her time was 2 hours less than Roger's, and it wants to know how far did they travel. Looking for the distance. They don't give it to us. That makes sense? Are they going to give you a picture? Are you going to draw? No. I'm not going to draw. I'm not going to give you a picture. I'm about to. Roger started here. Where did he go? It doesn't really matter. Okay, that's where he went. What about Judy? Same spot. Does that make sense? So distance equals rate times time. That's your formula, right? What do they tell us that we can fill in? This is Roger and this is, oh, not M. I don't know where I got M. What do they tell us? So Roger here, 12. The rate is 12, okay? Okay. This is the time of Roger, right? And Judy was less than Roger's time. Does that make sense? Yeah, multiplied. Do we know the distance? The distance is, we don't know, right? Yeah, 12 times TR. What formula can we take here? Right? Okay, and what distance, or what formula can we make from Judy's? Minus 40. If you went ahead and distributed it, 20 times TR, 20 times negative 2. Does that make sense? Now what? D and D, they're equal, right? So 12 TR equals what? Does that make sense? This is his rate times his time, right? And this is rate times time for Judy, right? So if they go to the same distance, rate times time is equal. Does that make sense? Okay. So what would you do to solve? Okay, get negative 8 TR equals negative 40. Divide by negative 8. Take it. Does that make sense? The time of Roger. That's why I put the sub R, so that I knew whose time that was. Does that make sense? The 40? From 20 times -2. Any other questions on how to get the T sub R? Okay, what did they ask for? So 5, is that my answer? What do I need to do to figure out my distance? Plug it in here. So distance equals 12 times 5, 60, what? Miles. Does it matter if I plugged it in here or here? Could I plug it in here? 5 minus 2 is times 20. Got the same thing, right? So it doesn't really matter which one you plug it into. You see how this works? Any questions on that? Okay. Brer Rabbit hopped off toward the briar patch at 10 kilometers per hour at 10 a.m. At noon, Brer Wolf began the chase from the same starting point. If he caught Brer Rabbit at 2 p.m., how fast did he run? What should I put here? Rabbit and wolf. If you want to write it out, you can. If you want to write out rabbit and wolf, you can. What information do I have? The rabbit started at 10. Okay. How can I fill that in? We want to draw a picture? Okay. Rabbit started off. Where'd he go? Okay. And then wolf started at the same spot though, right? And then what did they say? He began the chase at the same starting point, and then what happened? He caught him. So did they end up at the same spot? They ended together. Does that make sense? Yeah, they started at the same spot. Yeah, they just started later. Does that make sense? So they went the same distance, right? So do we know how fast the wolf went? So the rate of the wolf is unknown. Okay. What about the time? Okay, so how long did the rabbit run? 11, 12, 1, 2, right? Do you agree? The wolf, how long did he run? From noon, 1, 2. He went 2 hours. Make sense? Do we know the distance for them? We know, yes, we know that it equals 40, but we don't actually know the distance. Technically. But yeah, you can figure it out as 40. Does that make sense? So we know D equals 4 times 10. And D equals what? Yeah, 2 times RW. Does that make sense? From D equals RT, I wrote it backwards on this one. I didn't really mean to, but. So what is 40 equal? To RW, and so RW would equal how fast did he run? 4 times 10. Rate times time for the rabbit is the same thing as the distance. Was it? No, it wasn't miles per hour. Kilometers. Does that make sense? Any questions on these? Okay. All right, we know that ratios for corresponding sides of similar triangles are proportional, right? Rather than use a scale factor, we can use proportions. I didn't teach you to use a scale factor for triangles because you just don't need to know it really. So it's basically what we've done. How can we set up a proportion for these? 7. right? And you know what to do? You could also do it using scale factors. You know how when you have your parallel lines, it'll use a scale factor? You can do it the same way, but with triangles, it makes more sense to do proportions because that's what you're going to do in pre-calculus every time. You're not ever going to use a scale factor, okay? So this part is pretty much review, so I didn't do an example of it. So see if you can set up this problem and figure out how far they traveled. Does someone want to go draw the picture of what's happening? Do you agree? Hold on. There it goes. All right, let's step back and let them see if they agree. Do you agree? I don't agree. There's just one thing. This should be 14 instead of 12. That's it. Okay. Other than that, I agree. Did y'all get 9 for the time of Bill Vera? No, that's not the answer. How do you get the answer? 14 times 9? Did they travel 126 miles? I'm guessing. I don't remember what the problem said. You agree? Y'all understand how to do these? Are they only going to be same distance forever? No, they will add in other kinds. We'll do a separate lesson for different ones. Okay. Any questions on these? Okay. Use proportions to solve for x and y. Yeah. I don't feel the need to teach it using. Scale factors, you would have said, and so 7 times 5, 6 would give you y. Oh, no. 7 times 5, 6 would give you x. And 9 times 5, 6 would give you y. We did it with parallel lines, so I don't see how it's really relevant to using them on the triangles. Does someone want to go write their proportions? Yeah. Most of the time, whenever they're similar, they're not going to be whole numbers. Do you agree with him? Yes? Okay, go ahead. If you want to. You don't have to. Do you agree? Yes? Any questions on these? That's basically what you've been doing. No change, because I didn't teach it with scale factors for these, because I don't see the point in it. But, I mean, if you want to learn it using the scale factors, I don't mind teaching it that way. I don't care. Any questions on these? Okay. Your test tomorrow